All right. So talking about how we state our conclusions. So there is some nuance to the wording that we have here. So if the null hypothesis is rejected, the conclusion of the hypothesis test is very straightforward. We conclude that the alternative hypothesis is true. So that is kind of your book's opinion on it. I will also say there is a little slightly different opinion about that. It's not so much the null hypothesis is true, but we have evidence to support it. So what really you're saying is that evidence supports the alternative hypothesis. Or let's say alternate hypothesis. So that's probably a better way to look at it, because in statistics, we hate saying that something is true. We hate saying things are certain. Like I said, this is kind of your book stance on it, that it's true. If you looked at other books, took other statistics classes, you may look at this as not necessarily true, but the evidence supports it. So if the null hypothesis is not rejected, we say that there is not enough evidence to conclude that the alternative hypothesis is true. So another way of saying that is we're not ever going to say that the null hypothesis is true. We'll just say either the alternative hypothesis is true or not, or if the alternative hypothesis is true, we have evidence to support the alternative hypothesis. If the alternative hypothesis is not true, then we do not have evidence. Or sometimes we say not sufficient evidence to support the alternative hypothesis. Okay, so like I was saying, remember certain keywords here. Null hypothesis is rejected. Let me highlight that instead. Alternative hypothesis is true. Null hypothesis is not rejected. There's not enough evidence that the alternative hypothesis is true. So keep those in mind. I find usually with hypothesis testing, you could do a lot of the calculations. It's just this part here is where we get a little stuck. It's just remembering. If we reject the null hypothesis, that means we supported the alternative hypothesis. If we fail to reject the null hypothesis, we can't support the alternative hypothesis. So, like I said, this is not saying that the null hypothesis is true. What we are saying is that the null hypothesis might be true. So never are we ever trying to prove anything about, like I said, even though it's like we're putting the null hypothesis on trial, we're looking really for the evidence to convict it. So, it's like criminal cases. We may bring somebody in, we're fairly certain they committed a crime, but we don't have the evidence to support it. So deep in our thoughts. So a good example would be the O.J. Simpson trial. Is that the assumption always is he murdered his wife. But we can't say that because we couldn't prove it that he didn't. We just say we can't prove that he did. So it's kind of like that. So we can't ever prove the null hypothesis. We can just not really just, we can't prove it guilty is really what it is. So like I said, so it's not saying the null hypothesis is true. We are saying that the null hypothesis could be true. Like we said, we didn't say when we didn't convict O.J. Simpson that he didn't kill his wife. We just said he may not have killed his wife. That's really what we were saying there. Like I said, that's kind of an example there. Whether he did or not is not the point, but that's kind of the idea of looking at this, like you're looking at it as a trial. So in hypothesis testing, you either you reject the null hypothesis and you say the alternative hypothesis is true. You fail to reject the null hypothesis, and then you just don't have enough evidence that the the alternative is true. However, the alternative hypothesis, let's try this again. If you reject the null hypothesis, you do not have enough evidence that the alternate hypothesis is true. However, the null hypothesis might be true, is what you're saying. So we never ever say that we are going to basically, we're never going to say any kind of statement that's going to back the null hypothesis saying this is the true statement. We're just going to say either it's completely outright false, or we're going to go the other way, which is it might be true. It's one or the other. So boxes of cereal, once again, what we could talk about, are labeled to contain 20 ounces. An inspector thinks that the mean weight may be less than that, so he performs a test. And there's a little typo here. So we had stated this already, that with the boxes of cereal, that the null hypothesis is that boxes of cereal are what they claim, they have 20 ounces in them, versus the null hypothesis, which is going to support what the inspector is thinking, and which is that they actually, on average, have less than 20 ounces. Meaning the cereal companies are lying to us. Like I said, not every cereal box is going to have 20 ounces. What we're looking at is like if we average them out, they're supposed to be 20 ounces. And the inspector's saying, no, if we average it out, we're actually getting a little less cereal in each box than we were supposed to. So by appropriate conclusion, if the inspector rejects the null hypothesis, that means the inspector found that this hypothesis is actually true. So because the null hypothesis is rejected, it's gone. We don't care about it anymore. It is rejected. We conclude that the alternative hypothesis is true. Yay, it is true. We conclude that the mean weight of cereal is actually less than 20 ounces. We said the inspector is right. However, this could also happen. We want to state the appropriate conclusion if the inspector does not reject the null hypothesis. So if they do not reject the null hypothesis, basically we're kind of holding on to it. It might be true. So because the null hypothesis is not rejected, we do not have sufficient evidence to conclude that the alternative hypothesis is true. So we're sort of softly rejecting it. We're a bit more than anything just saying, well, it's not. We can't prove it. We can't prove OJ murdered anybody. That's what that one's saying. However, it's like there's still, we can't say that, well, he's totally innocent. We just go, he could be innocent. But like the same thing here, because the null hypothesis is rejected, we do not have sufficient evidence to claim the alternative hypothesis is true. I can't claim the inspector's claim. He could be wrong. I don't really know, but I can't say he's true. It's true. In other words, there's not enough evidence to conclude that the mean weight of cereal boxes is less than 20 ounces. That's all I can say. I can't say it is 20 ounces. I can just say, I don't have evidence to say it's less than. Like I said, it's just very picky on the wording because of actually what we're figuring out when we're figuring out probabilities. So just bringing this one up again. So I lost my tool there. We know that the population mean of IQ scores is 100. Researchers claim that lead exposure during childhood lowers IQ scores. They perform a test where we're going to say our null hypothesis is that, well, actually, those exposed to lead still have an average IQ of 100 versus the alternative hypothesis, which needs to be rewritten here, which is that their mean IQs are actually less than 100. So we think that they've gone down. So state the appropriate conclusion if the researcher rejects the null hypothesis. Well, if we reject the null hypothesis, then we have evidence to supplant for the alternative. We have evidence to support the alternative. Or in other words, we have evidence that lead exposure is better causes I hate using the word causes, but essentially it says we have evidence that lead exposure causes a decrease in IQ scores. And like I said, because I hate causes, we'll use linked because I didn't actually do any kind of research study here to say it's a causation, but it's definitely linked. We have evidence that lead exposure is linked to a decrease in IQ. Now, if I fail to reject the null hypothesis, that means I can't claim this hypothesis at all. So I have to say, we do not have evidence to support the alternate hypothesis. Not used to typing on this keyboard, sorry. Or another way we say this is that we do not have evidence that lead exposure is linked to a decrease in IQ. And this is essentially what we do when you hear researchers saying we don't have evidence to support this. It's because they did a hypothesis test. They looked at see what's going on normally in the population, and they want to see, you know, like, is there an effect from this thing? So like, controversial one, but like vaccines, the evidence is more in support from, you know, these hypothesis tests that they're seeing that they do not see this big difference between autism and the rest of the population, those that are vaccinated. It's probably hard to kind of figure out when everybody's vaccinated, but that is what the evidence is showing us, and they're basing that off hypothesis testing. However, we're going to see here is that sometimes we're wrong. So even though our tests may say we support this one claim or we don't have evidence to support this claim, there's always a chance that our evidence is their evidence is wrong.